Hello everybody, I am incredibly excited today to give you the first demonstration of quite a sophisticated AI running on blockchain. That blockchain, of course, is the internet computer, the only blockchain in the world today that can run compute at scale.
Web3 is changing faster than most people realize. The loud projects get the attention, but real progress is happening quietly in the background. Developers are tired of forcing apps to run on platforms that can't handle real workloads. They're looking for something stable, scalable, and actually useful. That's why a growing group of teams is turning toward ICP again. The shift isn't dramatic on the surface, but the reasons behind it are powerful. This video breaks down why developers are moving toward ICP in 2025, what makes the platform different, and how its architecture is becoming a serious advantage for real applications. This video is created for educational and informational purposes only. It does not promote or endorse any financial product, investment, or cryptocurrency. All information presented here is based on publicly available sources and independent analysis. Viewers are encouraged to conduct their own research before making any financial or technological decisions. The shift happening inside Web3 right now is not loud. Most people don't notice it because it isn't built on trends or marketing pushes. It's a calm movement under the surface, but the direction is clear. Developers are looking for platforms that actually work in real conditions, not systems that only shine during bull cycles. That is where ICP is quietly becoming relevant again. Developers, founders, and even small teams keep exploring alternatives to the usual set of blockchains. Many of them come from ecosystems where they spent years trying to scale applications, reduce costs, or manage complicated infrastructure. After dealing with multiple tools stitched together just to run one basic project, they are looking for something more stable. ICP fits into this search because it offers a complete architecture instead of a patchwork design. It brings the full application stack on-chain in a way that feels familiar to traditional software teams. To understand why this shift matters, it helps to look at the broader environment. Most blockchains still depend on centralized hosting, even if the smart contract layer itself is decentralized. Data gets stored off-chain. APIs sit on cloud servers. User interfaces run on Web2 hosting. Every piece of the application lives somewhere else. It works, but it creates friction. It introduces costs, it adds risk, and it forces developers to constantly monitor systems that should have been secure by default. ICP approaches the structure differently. It lets applications run entirely inside a decentralized environment. A single setup can hold logic, storage, front-end files, and user management without reaching outside the network. Developers don't need to maintain separate servers or constantly worry about centralized vulnerabilities. This alone is one of the biggest reasons small and mid-sized projects are quietly testing ICP. It reduces the number of moving parts, which reduces mistakes, which reduces cost. Performance is another important point. Over the last year, the network has improved speed and stability. For many teams, these upgrades remove the limits they used to face. ICP is able to handle applications that require frequent updates, heavy data usage, or quick response times. Instead of building minimal smart contracts, developers can build complete services. They can design social networks, AI apps, game economies, data tools, or consumer dashboards without relying on external bandwidth or cloud layers. Chain key technology adds another layer of attraction. It handles cryptography behind the scenes, so applications stay secure without extra engineering. Developers don't need to manage private servers or complex keys. The network's architecture simplifies operations, and that gives teams more time to focus on product development. When the foundation is stable, developers can build faster and reduce errors that usually appear during launches or updates. Cost efficiency plays a large role too. Gas fees are unpredictable in many ecosystems. Cloud hosting costs jump when traffic increases. These two problems combined can suffocate small projects. ICP reduces both issues because storage and compute resources run on predictable cycles. Teams can scale user bases without panicking about sudden spikes in operational costs. This is especially attractive for projects dealing with AI models, large databases, or real-time user interactions. Another reason developers are switching is the nature of ICP's canisters. They act like containers that hold the entire application instead of just the smart contract layer. This allows apps to maintain state, data, and logic in one location. It brings blockchain closer to traditional software architecture. A developer who previously needed multiple services to run one feature can now manage everything from a single environment. The growing interest around on-chain AI is also pushing attention toward ICP. Many blockchains have discussed AI integration for years, but still rely on off-chain models and external servers. ICP allows teams to store and run data-heavy AI models inside canisters. That makes training, inference, and data processing easier to control. For developers working on AI-driven products, the idea of serving models directly from a decentralized environment is appealing. It simplifies the pipeline and increases trust because users know the system is not controlled by external servers. User experience is another topic that often gets ignored in blockchain conversations. People want easy access to apps. They don't want 10-step processes, additional wallets, or confusing logins. ICP provides smoother authentication and wallet-free access that feels closer to traditional platforms. This helps developers attract mainstream users because the entry point is not complicated. When users find it easier to enter the app, retention improves. And better retention is one of the strongest reasons developers choose a platform. Developer tools on ICP have evolved too. Early on, the learning curve was steep and documentation felt incomplete. Over time, updates improved everything from SDKs to libraries and interface tools. The environment feels cleaner and more accessible. New developers are able to build functioning prototypes without feeling lost. This opens the door for Web 2 engineers who want to experiment with blockchain without leaving their familiar workflow behind. SNS, social networking service, governance has become another attraction. Many blockchains require third-party tools for DAOs. ICP lets developers launch full decentralized governance systems directly from the network. Token distribution, voting, treasury management, and control systems are all available as built-in features. Instead of designing a governance layer from scratch, teams can activate one that already matches the network's logic. This saves time and dramatically reduces technical overhead. Interoperability is growing as well. Chain key cryptography allows ICP to connect with other blockchains directly without using traditional bridges. This increases security because bridges are often the biggest vulnerability in cross-chain systems. Developers can access assets, data flows, and external chains without trusting third-party infrastructure. As more ecosystems open up, ICP becomes a connecting layer instead of just another isolated chain. Web 2 developers are another group exploring ICP. They've built applications on cloud platforms for years and understand the limitations of those systems. When they begin experimenting with blockchain, they find that most chains don't offer familiar application structures. ICP stands out because it supports a more complete development model. It feels closer to building real software instead of writing small contract fragments. This familiarity makes the transition easier, and that attracts teams from outside the crypto world. Large-scale consumer apps are paying attention as well. The ability to run big user bases without worrying about gas fees or external hosting gives ICP a practical advantage. When companies experiment with decentralized alternatives, they often struggle with performance or cost. ICP offers a balanced approach where applications stay decentralized but still handle real-world workloads. This combination is uncommon in the blockchain space. As the ecosystem grows, more developers share positive experiences. The early days of ICP came with misunderstandings and unrealistic expectations. Over time, steady improvements reshaped the narrative. Instead of chasing headlines, the network focused on technology. That shift built trust inside the developer community, which now values results over speculation. Many developers who switch to ICP describe similar reasons. They want stability. They want predictable pricing. They want full-stack capability. They want a platform where everything works together without forcing them to stitch services from 5 different providers. They want speed without sacrificing decentralization. They want a place where AI, storage, compute, and governance exist in one environment. Another reason developers are migrating is the reliability of cycles. Traditional gas models can create sudden spikes during high network traffic. ICP's cycle model keeps operations predictable. Large apps, especially those with constant activity, prefer stable costs. Developers can calculate long-term expenses more accurately, which helps projects plan budgets, raise funds, and maintain financial control over the product's growth. Real-time applications benefit from ICP too. Social apps, chat platforms, interactive dashboards, and multiplayer features need fast responses. They cannot function properly on slow transaction models. ICP's architecture allows these applications to behave more like normal Web 2 services while staying decentralized. This performance stability gives developers confidence that their product won't break under pressure. Another subtle but important point is regulatory comfort. Many teams feel safer building on networks that don't rely on opaque multi-party tools or centralized infrastructure. ICP's design reduces the number of external dependencies, and that simplifies compliance. Developers planning long-term projects prefer environments where rules are easier to follow and control is transparent. The quiet shift toward ICP also speaks to a larger trend in Web 3. People are moving from theoretical innovation to practical infrastructure. Hype cycles may draw attention, but meaningful adoption requires platforms that work consistently. ICP is becoming part of that conversation because it solves everyday problems developers face. This does not mean ICP will replace every blockchain. Each ecosystem has its own strengths. What it means is that ICP gives developers a place where they can build full applications without compromise. It offers a stable foundation that covers storage, compute, security, user access, AI, and interoperability all in one place. As more developers experiment with the network, the shift grows. It's not loud, but it's steady. And steady movements often matter more than noisy trends. Real adoption usually begins quietly, not with headlines. The hidden power move behind ICP's growth is simple. Developers are switching because it finally gives them a platform that matches the complexity of modern applications. It handles more than transactions. It handles the full experience. It gives teams the room to build serious products without worrying about the limitations that hold other chains back. All right, if you learned something new or enjoyed this video, make sure to hit that like button, subscribe to the channel, and turn on the bell icon so you don't miss future updates. Thanks for watching, and I'll see you in the next one.